Yeah, hello everyone. So today we are looking at a few issues in our backlog. We'll start with the binary data proposal that I wrote a spec for. So my goal would be to just go over the document, or parts of the document, I should say. So we talked about most of the stuff last time already. So the key changes from last time is we need a stable API. We can't ship preview right now. The other thing I added was effectively just the assembly name and the package name. So I went with a very boring approach. I just took the core type name and made that the assembly and package name because that's the pattern we used elsewhere. And so unless there's more questions around that, I would just try to use this meeting to just close on the API. So effectively last time we had a slightly different proposal where I tried to make everything instance methods, so we can use extension method signatures to basically factor some of the functionality to higher levels. I think we convinced ourselves that that's over-engineering or not really necessary because we think of binary data as a high-level exchange type, not a low-level thing we would use in MS Colib. So in that sense, it's acceptable that this thing directly depends on basically a JSON serializer or whatever else we need. The primary reason why we would do that is to increase usability, because if we make extension methods, they have a somewhat of a wacky calling convention where you new up the object and then you call a method to actually fill it, which is a bit weird, rather than just creating the object and then basically letting the object creation, whether it's a factory or a constructor, fill the thing. And so once we go down that path, now the question is, should we go with constructors or with statics? The downside to using constructors is that they're unnamed, right? So the basic problem is now if we have something like this signature here where we have basically a type that gets serialized, it's somewhat challenging to add another serializer later because now we would have to somehow manage to overload this thing. So one way we could do this is we can overload this method, have another argument that is like, serializer, which is an enum or an abstraction. The problem with that approach is that that makes the API extremely unlinker friendly. So imagine binary data would basically support both, system text.json and let's say protobuf. The linker is not able to remove one of them if you only use one of them because it can't tell which one you're ending up using because you're effectively passing in the thing through, as an enum, for example, right? If we go down with an actual abstraction, then maybe we can, because then the idea would be that you construct the abstraction and then the abstraction itself depends on the serializer, not the actual implementation of binary data. But that still is somewhat challenging when you think about defaults, right? So because people don't know necessarily that it does JSON, right? It says it here, but like if you actually new up the thing, you don't know what's happening. Versus if you look at a factory, like it clearly tells you what it does, right? It would say from object as JSON, so it tells you that it does JSON serialization, right? So there shouldn't be any surprises. The downside of a factory is, of course, is that they are somewhat less discoverable because you can't new up the thing. Last time we said binary data was a struct because it only holds onto effectively a single pointer, which a struct can do just fine. But that also no means that structs always have a constructor, right? The implicit one that doesn't take any arguments. If you make this a class, then we can get rid of the default constructor, which means you can't get, you basically can't say new binary data. The code wouldn't compile. So the hope is once that's the case, developers are used to the idea that, oh, maybe there's a static method I can call. So that's basically the trade-off. Now, my personal opinion is that given that this type is designed for usability, that's literally its only goal, really. It doesn't do anything that you can't already do. It's really meant as a one-stop shop for people to effectively convert data from into binary representations that are common in the framework without thinking too much, right? So if the type is not usable enough, then it no longer realizes its values, right? And so that's kind of
one question on that.
Sorry, yeah.
So I just wanted to confirm. You mentioned earlier that this type would never be used in core lib. This type would never be used anywhere in any of the shared framework, right? Like pretty much the only place it would exist in .NET runtime is the type definition itself.
Yeah, so that's something we can decide. I wouldn't say it can't be used anywhere in the shared framework. It's just basically because of it depends on system text.json. It could only ever be, at whatever the layer is that system text.json is, right? So it would be fairly high up, right?
Yeah, I'm asking for that reason, but also just to clarify performance goals. If it really is, never going to show up in any API anywhere in .NET runtime, that's one thing. If it might kind of, sneak its way in somewhere, I fear we're going to find ourselves starting to talk about performance on a type that was never designed for it.
And
so
Steve,
I kind of feel like, sorry, go ahead.
What do you worry? Which of the APIs that you see on the screen you would worry about in terms of performance?
Well, that for the most part, this is going to many of these conversions or some of these conversions are not cheap, which is fine. They're not supposed to be. You've got your data in one representation and you need to marshal it to another. Go from a span to an array, like that's an allocation and a copy of the whole data, right?
Right.
So that's we have to be very. So I just want to confirm that, like, as part of introducing this, we're also saying that even though this is an exchange type, we're not going to add overloads that take binary data pretty much anywhere in .NET Run.
Yeah, so the way I think about this is, and Christoph can chime in here, but the way I understand this API is that it's really meant for receivers that basically dump data somewhere else. So for example, if you think of the example I have in this document is you talk to the Azure queuing APIs, right, that just add a queue item somewhere. Fundamentally, the data in the queue is a binary blob, so you basically get to pass in the binary blob. But realistically, your data is not in binary form already, right? It's either an object graph, it's text, or basically something that you already have in some other form, right? And so by basically just giving this type here, yes, you're right that some of these overloads here end up copying. My understanding is that the one that takes read-only memory wouldn't copy. The one that takes span, byte array, or streams, of course, would have to drain the data into the object, right? But then from there on, once you have the data, like the data itself is no longer copied, right? So then when you pass it around, given that the data is effectively stored as a read-only memory, that's why we have this 2 bytes method here, which basically gives you back the underlying data, right? And so it's no longer copying after that. But yes, you're right. The initial thing might not be super cheap to produce, but that's probably for the purpose of the API what the user already has to do anyways. So it's not like this is super inefficient.
And that's fine. Like I have no problem with this for the high-level APIs.
Right.
But like I worry that there could potentially be a slippery slope where, we say, well, rather than adding 10 different overloads that take span and memory and string and byte array, well, let's just add one that takes binary data.
I see.
And I also worry that we're going to end up, if we don't have a firm line in the sand, this is going to be the classic cartoon of there are 15 standards right now. Let's add one to rule them all. Now we have 16 standards.
Right.
And we're going to end up with, the 10 overloads plus the extra one for binary data. So I just want to make sure we're very clear on what the purpose of the type is.
Right.
And and that we're really focused on usability and not at all on perf.
Yeah. So I think that I can clarify or add something here. This type is not to represent kind of unify different representations of binary data. So as you said, it's not a type that would represent either a span or memory or byte array or some other things. It is a type that makes it easy for people to convert from strings and objects to binary data and the other way. So it's a helper for basically conversions, not a unified representation. And yes,
and that's fine. Sorry, go ahead. I thought you were done.
And then therefore I would say I would not see it in low-level APIs that, as you said, today take read-only memory and span and so on. In general, I don't know if it's if we would never get pressure from people to add it to some other APIs, but I would say I see it more in APIs, kind of in ASP.NET. Recently there was a kind of set of extension methods that use HTTP client. Extend HTTP client to kind of send and receive JSON. I think it's along the lines of these extension methods rather than a unification of span and read-only memory.
Well, that's that makes total sense. But that also makes me think like what we're really talking about here isn't a type so much. We're talking about a bunch of conversions from A to B. And the only reason we're talking about adding a type that's instantiable is because there's 10 things that we're converting from and 10 things we're converting to, and we might want to add more in the future. And we don't want the full product of all of those yielding 100 methods.
Yeah.
But that would also suggest that we wouldn't want to see this in any signature. That
Yeah,
would just be for. Sorry, go ahead.
No. So actually, sorry for kind of interrupting you a bit, but I think at the core of what this type offers is that it would show up in signatures of high-level APIs. So the reason, so we actually explored just having a bunch of helpers for, let's say, read-only memory of byte. And but what we observed in usability studies, you probably know that you've seen it too. People basically want to use IntelliSense to discover what to do with APIs. So they see a method, and let's say the method takes read-only memory of byte, and they want to send either a string or an object serialized. And now they are like, oh, how do I get read-only memory of byte from a string, let's say? And some people know how to do it, but it's read-only memory of byte is a new API, and even if it was a byte array, people are still not as familiar with all the encoders that we have and encoding APIs. Now we developed this type, and we put binary data in signatures of these methods, and literally all problems went away. And they went away because the user sees binary data in the signature and says, okay, well, then I need to instantiate binary data. They call the binary data constructor, and they see several overloads, and one takes a string and one takes an object and says, this is going to be JSON serialized, and they literally just fly through the API. So I think the value of the feature does depend on it being a type that you can instantiate and a type that shows up in signatures of methods.
Well, and that's where I'm concerned about the slippery slope of this, is that we are going to see it start getting pushed down. And so any decisions we make here based on usability and saying perf doesn't matter is going to be problematic.
Yeah. And second thing, so I only mentioned inputs, and the same thing is on outputs. So imagine that we have lots of APIs that retrieve some data from Azure, and in the past we would return read-only memory of byte, and the user wants to get a string or wants to get to deserialize this binary payload and get JSON or deserialized JSON object, and they would have to deal with all these APIs to do deserialization or encoders, decoders.
Sorry, just quick question on that front.
Yeah.
Sorry, just a quick question on that front. I'm looking at the API you're talking about not having to deal with encoders. What does it mean to create a binary data from a string?
We basically just transcode it to UTF-8.
Why is that implied?
Because that's literally what every single networking protocol does.
Yeah, if this type is meant for usability, I think it's okay for it to be opinionated in regards like that.
I mean, we considered, we had prototypes that, let you specify the encoder and transcode to copy to UTF-16, but we kind of realized that it's completely useless. It just adds surface area and complexity, and nobody needs such APIs.
I mean,
and these scenarios, oh, sorry, go ahead.
Yeah, so one way to think about this is that really what this type does, it basically allows you to take your data and put it into a binary blob representation, right? And you are usually the only party that retrieves it. So at the end of the day, whether you code UTF-8 or UTF-16 is kind of an implementation detail anyway, because you just say, I want to put stacks into this binary blob, and later on I want to retrieve the stacks from this binary blob. You're not really coding to somebody else's specification, right?
You are coding to somebody else's specification if there are public APIs that accept this.
Well, it depends on what these public APIs are.
If I have a method, the HTTP client example, if I have a method that takes a binary data and sends it, like it needs to assume that it's a particular encoding, or it needs to be told what the encoding is.
Well, but the thing is,
Yeah.
like you say somebody else, right? So, for example, take the Azure Blob Storage, the Azure queuing example that I have from the doc, right? It's a public API for the queuing layer, right? But you are the party who puts stuff in the queue, so you're also the party that retrieves stuff from the queue. So long you are consistent with what you use to retrieve the data, it's fine, right? Because you just treat this thing as a binary blob. You put text in, you retrieve text out, right? So in that sense,
not the case that's not the case with the JSON example, for example.
why is that not the case?
I think, I think, Steve, you're actually missing a little bit of context here. So I think you missed the very first time this came through review, where there was a constructor on this type that actually did take object, and the opinionated behavior of this API was that it would call through system text JSON because the API would be locked to the JSON stack. And one of the pieces of feedback that we gave at the time was, like, while this might be fine for something like string to go through UTF-8 because like that encoding has won the encoding wars, JSON has not demonstrated yet that it has won the serialization wars. Like, it's there are competing standards, and if you're serializing something as a binary blob, who's to say that in 2 or 3 years' time the world would not have moved on to a more compact binary representation, something other than JSON?
No,
Yeah.
I'm not at all disagreeing with that. The JSON example I was citing was the one that Christoph brought up of extension methods on HTTP client that post data as JSON. And if that takes a binary blob, you as the consumer of that API are creating the binary data to hand in, and the consumer of that, the API itself needs to pull out those bytes and know what they are. And so this isn't the case where you're both the producer and the consumer. In that case, I'm just pushing back on what Emo said. In that case, you are the producer of the binary data, and something else, the framework implementers, are the consumer of that data, and therefore there needs to be an agreement of what it means.
Okay, yes, I agree with that.
Well, then I would say those scenarios to me would be easy to justify where they're out of scope, right? I mean, like if you actually just use HTTP client to publish data to the server and there's no interpretation on the HTTP layer, on the HTTP layer, it's just you send a blob to the server, and then on the servers you do the exact same thing. You say binary data from that payload. It's also fine, right? Because then you just still agree on it's binary data on both sides. And then as long as you're consistent on the production and consumption side on which methods you call on binary data, it's fine. It's really,
but that's not the case if you're posting. If that's not the case if you're posting JSON to some arbitrary, JSON-based web API, which just gets to my point of like,
right.
If we say that that's out of scope, I'm concerned about this type showing up in public APIs anywhere in .NET Runtime, just to kind of bring this full circle.
Yeah. In these scenarios, we have the content type header, which is a piece of metadata that exists separately from this type that tells you how to interpret the type. Without that secondary piece of metadata, you're right, you wouldn't know how to interpret this unless you had a private agreement with the receiver.
By the way, we considered adding a field to this type that describes basically it's a content type. But again, we decided we don't have concrete scenarios where it's needed, and if we ever want to do it, we felt like we can do it later.
Yeah, I mean, it kind of like, I mean, just to echo Steven's point though, like to me, basically there's two things you already know, right? One of them is because of our serialization dependency, this is a high level type, right? So we're never going to plumb it to the, all the way to the bottom, which everybody seems to be, okay with because it's a usability type after all, right? And realistically, given that this type gives you the ability to convert to any other exchange type, you're never really cornered, right? If someone asks for memory, well, you have a way to produce one. If somebody asks for a span, you have the ability to produce one.
Yeah.
So the question really becomes like, what are good use of the API? And I think, to me, like if we formalize what I tried to express earlier, which is the idea that you use it in cases where you really give the customer the ability to store arbitrary data and retrieve arbitrary data, I think it's the right type for the job, because then it's basically protocol neutral, because it's like the protocol is just, it's bytes. You put bytes in, you get bytes back out, but there's no obligation that you have to be within a certain envelope, whether it's JSON or UTF-8 or whatever, right? And I think that kind of makes it also clear where the type makes sense to use, right? In the Azure Blob Storage example would be good. The queuing example would be good, right? HTTP client to talk to an arbitrary REST service, probably not so much, because yeah, you have to know what the server wants to get. And this type doesn't allow you to do that. And I also would argue that we probably shouldn't make this type do that, because then the type gets more complicated, and then it kind of loses its primary value prop.
Yeah, I think another way to say it is it's mainly for user data. It's not for the protocol's data. But even users' data is basically UTF-8 because users just operate on, like, well, for starters, they use the UTF-8 JSON parser, writer, to write the data, so it's gonna be UTF-8, and then they just store it as UTF-8. In either queues, event hubs, or blob storage, or service bus, I meant. Yeah, but I mean, in general, Steve, I think your main point is about not complicating low-level APIs that already have many representations of bytes. And I completely agree with that. I don't see this type as a universal representation of bytes. I see this type as a helper for converting from using JSON serialization or encoders.
For those on the stream, Emo's typing right now. It's just you can't see it.
How can you see it?
Because I can see Emo's Teams window.
I can't type the word
It's just
keyword.
not on YouTube. I just realized it's showing up as an awkward silence on the YouTube stream.
Yeah.
I was not sure whether my microphone is still working.
No, we're all good.
So then basically what I'm hearing from Christoph is like through the indirect feedback of like basically we want the constructors, they're not the factories, right? So that means you would say this is way more usable than this one, right? Is that fair?
Yes.
I think that matches what we've seen too from usability studies. I wonder if there's a way for us to, like, if someone tries saying new some type, to have some kind of IntelliSense mechanism that says, oh, by the way, like, here's how you actually create an instance of this, like something that just kind of guides people toward the right thing.
I mean, you can basically by just writing an analyzer or a code fixer, right? So for example, a code fixer can work on any code. The code doesn't even have to compile, right? So you could say if somebody says new binary data, of data, you can say, oh, you can suggest to replace that to binary data dot from bytes, right? The problem with that is that I'm not sure that fixes the usability issues because, as Christoph said, right, people don't code like that, right? They basically open IntelliSense and they make decisions based on what they see, right? They don't type in arbitrary code and then try to make it work, right? So I feel like there is we have seen this so many times. I mean, the system text.json example was perfect, right? When we tried the serializer type and all the static methods we had, none of them were named serialize and deserialize. They all were called like toString or parse or load or whatever. And we could observe people not calling any APIs because they were just trying to figure out which one to call, right? And so I think like if you create these pauses where people just are stuck, they don't know what to do, it's pretty bad.
Mm-hmm. Yeah, the best workaround I can think of is provide a constructor, immediately mark it obsolete as error, and then have inside the error message, like say, hey, this is how you do it instead.
Yeah.
But obsoleting an API the moment we ship it is a bit weird because it means we've misdesigned something.
I mean, there is an experience you could do, which is kind of like, I've seen this in ReSharper, for example. They have this smart complete mode where you can basically say, oh, I need a binary data. Let's say you call a method that takes a binary data. And when you basically writing the argument for the method and you do Control-Shift space, ReSharper will suggest things that are in scope that can produce a binary data. That includes also factories on the same type. And so in IntelliSense, immediately you would see binary data dot from bytes and from object and all of that. But we don't have that. So I think, but that would be I think, the right UI metaphor to deal with that. But I'm generally hesitant to design APIs with the assumption that we will have tooling at some point when this tooling doesn't exist, and it's very hypothetical. If the tooling exists, I think I'm fine with saying that's not how people write code anymore. But I think that's not the case here.
If I remember correctly, the big pushback toward having constructors to create these things rather than factory methods was that we were considering a constructor that just took object, and it wouldn't be apparent that that was JSON serialization. Would it make sense just to leave that off?
There's also the fact that the stream receiving methods, the async versions of them, cannot be constructors. And so we will have factories, and it was how about we try, instead of mixing models, have just one, only one of them can have all of the things we want. So no constructors, only factories.
Yeah, I mean, one thing that I think, I remember correctly, and Josh and Christoph can correct me, but my understanding from the Java API review that you guys did was that you basically only use factories, right? Because Java had basically the same API surface. Is that a fair summary?
I don't remember exactly, but I think so.
I mean,
Java only uses the factory methods. We have the constructors because of the ambiguity with using a struct, where users might end up using the default constructor anyways if we didn't expose constructors, and they might never find the static factory methods.
Yeah, speaking of which, we should think, one thing I would want to talk at this API review is whether this type should be a struct or a class. I kind of, despite of the issue, or in addition to the issue that you mentioned, I also think that a class would give us a bit more flexibility. For example, we discovered some scenarios where a subtype would be better when it's returned.
Well, also, we're talking about copying potentially huge amounts of data. The extra allocation for the class itself isn't going to matter.
Yeah, exactly. So it could be class. But having said that, going back to the constructors, I think basically the three main scenarios for this type is I have an object I want to serialize. I have a string I want to encode. And I have a byte array and I just want to pass it through. And I think we should have these three constructors. They represent the mainline scenarios. And then there's many other from methods to methods that represent optimizations. Like, for example, today the constructors in the hybrid API listing that Timo has, we have constructors for spans, for byte array, for read-only memory. They are all optimizations, and I wonder whether we should not remove those and basically just have three constructor overloads that represent the common scenarios, and then say all the power is in the static methods.
So in that scenario, you had also mentioned having subclass types. Would the constructors be on the subclass type or on binary data itself?
On binary data.
Okay. Because I didn't know if you were going for like an HTTP content-like thing where you had like a JSON binary data, a string binary data.
Yeah. So mostly the return, the subtypes, we would use them on the return as return values. So users wouldn't even know the subtypes would be even internal. They would just, store some additional metadata maybe, and maybe change the serializer, the default serializer.
What's an example of where you would do that?
So we have some payloads where we know that, for example, the default serialization settings are not sufficient or don't work. So, which brings me to another point. Should we add an optional parameter that lets people, now that we basically, for context, for people who are not in the previous review, we in Azure SDK have an abstraction for serializers. This abstraction would allow people to switch from the default built-in serialization logic, as we have it right now in the type on the screen, to something else. So, for example, they could instantiate a new, an instance of system text JSON serializer, change the settings, and then pass it to this type and say, hey, don't use your own built-in default serializer, use this one. And very often it's done to basically do some transformations and conversions. So we were thinking about developing a subtype for some of our services that basically require that.
I mean, in principle, I think that's a good idea. I think in practice, given that we have only effectively like 11 days left before we have to ship a stable API, I don't think that's the best time to basically design a serializer abstraction because we have no way of previewing it. And my confidence of getting this right off the gate is not very high.
Yeah. I was saying, before we had this abstraction, we now removed it because we don't have it in the BCL. We are planning to have some extension methods and whatnot. What I was saying is, given that we now don't have the abstraction,
right?
I think we should add a parameter to the methods that use the system text JSON serializer that takes the serialization options. We may want to add it. I would actually be interested in Josh's opinion if we need it for service bus.
So yeah, so that's one thing I wanted to talk about. Like, I think in practice you need to take the options, because otherwise, if your type isn't serializable with the defaults, you're screwed.
Exactly.
Yeah, I do have concern with the constructor that takes object, just because it's JSON, and as Levi already mentioned, JSON has not won the war. In fact, it's now being on the downhill. But if the signature ties the JSON serializer options into it, then at least now you have a target that is obviously this is JSON. Yeah. It's not as clear as a named method, but at least now it's not taking the best overload and hand waving for what later may, like anything we have right now that uses XML, and somebody's like, why is it using XML? In 10 years, they'll be like, why was this using JSON? It's like, well, go back in time.
But I did notice that actually, if we added this parameter, it solves your problem that a constructor that takes just an object is now taken by some behavior that you don't feel is going to be valid, in 5 years, or you said in 2 years.
So I'm not following this one, Christo. Are you basically saying because it takes an additional parameter that is,
yeah.
But if you would make it optional, right? Which means the call side still wouldn't tell you, right?
Well, but well, maybe you're right. It's if everything is optional, then let's say in the future we add an XML serialization for the labs. It would have to take object XML serializable, and then XML serialization options that are not optional.
Yeah. If you look at Teams, I basically just typed it in. So like if that would look like this, right? But then if somebody just says new binary data object, now that code stops compiling.
No, I'm saying the XML parameters would not be defaulted.
That's
the way.
So you basically would say, okay, in this case, maybe you can do that one, but you would have to pass in this guy.
Yeah. Well, you cannot do a second parameter be defaulted, but the third one not.
Yeah. I mean, really, the serializer options
fair point.
become the second parameter in both of them. Because we know that would be the thing that needs to vary later.
Yeah. Yeah, I mean, this comes really back down to like constructors kind of suck for this scenario, right? Because you can't use generics, so you always have to specify the type. You can't name them, so that's kind of a shortcoming of constructors in general.
I mean, certainly my preference would be, even if we have constructors, to not have the one that takes object. I'm aware it's a common scenario, but it's bad for the language, or rather the language doesn't support it very well.
Right.
again, we want, like, the generic inference is very helpful in this case. The understanding what you're doing when you're calling this constructor. The notion that if you had a byte array typed as object, that when you give it to the constructor, it's not going to, de-alias the type, it's going to JSON serialize your byte array, as opposed to transport your byte array. Like,
unfortunately, the implications of removing this constructor are the following. People see the other constructors. They have an object. They want to serialize it. They see in signature of some, let's say, service bus method, binary data. Then they try to instantiate it. They don't see any constructor that takes an object and kind of implies serialization. They just see byte array and string. And now they start searching for serializer, and they use serializer to create a string. And
that's part of why my real preference is 0 public constructors.
And then 0 public constructors basically means 30% of people get stuck.
Yeah, I think that's kind of like, I think the question is, where do you draw the line, right? I think so clearly with async, people, you have to make the leap of faith that people will discover the statics, right? Because there's no way to make them asynchronously work, right? So the question is, if you are in async context, do we believe people get that, oh yeah, new is just one way of doing it, another one is a static, right? That's question one. I mean, you're basically saying, well, it's advanced scenario, so people should be able to do that. But I'm not sure I completely agree with that, because we make async kind of very popular for most people already, right? The other question is like, yeah, if we remove the serialization constructor, I completely agree that it looks weird if part of the data can be constructed via the constructor, the other part can be constructed only via factories. Right now, the split is basically only for things that are async in nature. So the only thing that's missing from the constructor is the stream one, right? Everything else is also on the constructor. So like, at least you get when you do new binary data, you get a sense for, 99% of the data that you can actually construct it from, right? And then it's just, oh, you don't want to do it synchronously, you want to do it asynchronously. Sure, factories might be then the next step, but yeah, I think if we really want to move the serialization constructor, I think at that point we should truly consider just not having a public constructor at all, because I think having that split would be extremely hard for people to understand. So I think, to me, it's one or the other. Either we say, yep, the serialization constructor is there, or we don't have any constructors. I would not do the thing in the middle.
Emo, take a look at what I posted in chat, where if you introduce an intermediate type, even something like a struct, you could actually have the word JSON appear somewhere in the constructor. The idea is that you would have new binary data, new JSON data, and then you would pass in your object there. If JSON data were an intermediate struct, then you wouldn't incur a perf hit here, and you would get proper IntelliSense all the way up and down the stack. It is somewhat of an old COM-like way of doing things, but just in the sense that you have a bunch of new statements. But again, new statements can be cheap or free.
I mean, I think that satisfies what Christoph said earlier about using IntelliSense to discover things. I will say though, like, if we ship this API, the immediate reaction will be that's very tedious, right? Because you have to type a lot of stuff here.
Maybe it does make it a little bit future-proof in the sense that if you need to support other types of data, like BSON data, then you would say new binary data, open parens, new BSON data,
right.
Open parens.
Well, the problem is just like, I think in Java you get away with this, right? Because in Java you have to write 10 statements to just create the factory that does the thing. But like, I think in .NET people want basically like a single method, right? So people will immediately turn around and say,
exists. It's from object.
So sorry, there was someone else cross-talking.
So the single method does exist. It's from object. It's people who use new and are fed by IntelliSense have a path, and the people who use the method have a cleaner path.
Oh, I see what you're saying. So basically, you would say we still have the factories that are static on the type, but if you want to go with the constructor path, that's how you would discover that you can do that. I mean, that's not terrible, but it seems like a lot of ceremony.
So let me explain the problems that I'm trying to solve here, and maybe this is the wrong way to solve them. But the problems I'm trying to solve are, like when you create the thing, you're led by IntelliSense to just start typing, and as long as you follow IntelliSense, you're going to be led into the right world.
Right.
And B, we don't have the type implicitly tied to a particular serializer without the word JSON being somewhere in the method name. Now, it's possible that maybe we collectively say we don't like that second thing. Like we want it to be opinionated, and we want it to say JSON is the way forward.
Right.
I've already expressed my concerns about that, but I mean, if we say that's what we want, then it's what we want.
I mean, I will say, like, the question really comes down to, I think we believe that JSON is not going to be the last serialization format, right? Because, well, we already have others, right? But the question is, if you assert that it's literally just for, give me some bytes, and I don't actually care what they are, I just want my object to be in there, and I want to be able to retrieve it later. So if you basically say the protocol, it's not relevant for the protocol whether I use JSON or something else, do we believe then there's a lot of pressure to remove JSON from this thing? Because realistically, the only reason why you would do that is because your object graph cannot be serialized using JSON, right? Because your object graph is like, I don't know, has cycles or other things that are not easily done in JSON, or can be done, but it's tedious. And the other one would make that super, super simple, right? Or maybe it's size, because, well, I don't care what the bytes are, but I care that it's not 4 kilobyte. I would like to have it like, 20 bytes, right? So if we assert that, then do we think that's still in the same ballgame as, oh my God, there's another serializer coming and we have to support them everywhere? Because I feel like for things that are protocols, it makes sense because people choose different things at different things. But here it seems more like, well, it's a black box, so as long as you can get the bytes what you put in, you should not care whether it's JSON or not. Of course, people have to care because they have to tweak their object graph in order to be JSON serializable, but that to me seems like a lesser problem.
But honestly, I would solve the problem of, future serialization technologies by just flipping the parameters in the object constructor. It's not ideal, but I think it works. It was a good suggestion because we will have to make the options parameter be not defaulted, so it cannot be lost. And then, future serialization technologies, you just, we add them without the defaults. It's not ideal, but I think it works. And I think I was talking about this in the last review of this type. I do believe that usability of the type has to be the highest when it ships for the first time. Once there's enough critical mass of customers who learn how to use this type, what it's for, what it's about, then additions are kind of easier. They don't have to be, frankly, as easy. So yes, the additional serialization options, somebody would have to pass, an option, or, still pass a default, but at least cast it and select the type. But I think it would work.
So when you say swap the parameters, which ones would you swap?
In the constructor, swap the serialization options and the type. Because if we ever add a new serialization type, basically it's good if the parameters are in the same order. So that also assumes that all serialization technologies have some options, but I think it's a fair assumption.
And so for XML, you then think public binary data of, let's call it XML serializer options, comma, object, to follow our pattern, XML serializable?
Yep.
Well, the object would still be first, right?
Yeah.
It would be XML serializable, and then XML serializer options non-defaulted, and then type optional, right?
Yep.
Oh, okay. I thought when you said switch the order for the other ones, you were saying put object second. But yeah, I mean, this solves the problem. It just means that we wasted a default. Like,
Yeah, I mean, depends on how you see that, right? If enough types are serializable with JSON and most people don't care what it is, then it would still add value, right? Which
Right. I mean, again, it's the just thinking into the future of if this is popular in high level APIs and nobody wants JSON because it has I don't know what percentage overhead it has compared to protobuf or whatever, and they're like, no, I want the messages to be smaller so they fit into an Azure Queue message because it's terrible when you have to split it or indirect it. That now what you have is the majority of cases are passing protobuf serializer options.default as the second argument, just so they can get the which constructor overload was I trying to call. And that means that we burned the default on the thing that people don't want. And we expect it's going to be the thing they don't want within a relatively short amount of time.
Having said that, we would still add the factory methods for protobuf, which means people kind of already understand the type, understand this, what it's about, and now we just have a blog post and say we now support protobuf 2, and by the way, there's a factory method, and you don't have to pass the options if you're happy with the default.
Right.
Can we discuss one more thing that I think is a leftover from having the serializer abstraction? So we used to have serializer abstraction, as I explained. We removed it because it doesn't exist in the BCL, and we kind of I think manually just converted the APIs, which means we have async APIs. Do we need async APIs given that now it's basically a built-in system text JSON serializer, because it's just serializing objects in memory to a buffer in memory. There's no I/O going on. There's no reason to call async APIs. When we had the serializer abstraction, we needed to have async APIs because some implementations of the abstraction actually do I/O as they serialize. For example,
you'd still want it for stream.
Yeah, still want for stream, but for the from memory to memory, we don't need it. Correct, Josh? Josh and Ted, chime in if you remember any other reasons.
The from object async ones and to object async could go away.
Yeah.
Sorry, I didn't quite follow why. Why would you have why would the serializer abstraction require async? You had something.
Because one of the implementations of the abstraction was a serializer that communicates with the schema registry. So schema registry is a service that stores schemas.
I see.
And during serialization, the serializer would actually go, hit the service, retrieve the schema, and validate that everything, that the object matches the schema or the payload matches the schema.
Gotcha.
Right now, since we don't have the abstraction, the default serializer basically just, serializes data in memory, therefore no I/O is happening.
Yeah, I think we can get rid of them. Weren't we going to put as JSON and from JSON on the to and from object methods?
Sorry, I didn't hear the question. Can you repeat?
When you and I talked yesterday, at least, we talked about from object as JSON and to object from JSON instead of just to object and from object.
That would work for me, Krista. What do you think?
I think it's fine.
Yeah, because that way when we get the protobuf, it's from object as protobuf. Then the options can be defaulted, where you just say yep, doing the default stuff.
One question I have is, so we have an implicit conversion from binary data to read-only memory. Should we also have one for read-only span?
Maybe.
Because at that point you can pretty much pass this type everywhere, or close to everywhere.
It's going to be a class, right?
There will be an implicit OFN copy operation.
Right.
Why would there copy to go to read-only span?
Because this is not a ref struct, so you have to copy the contents of the read-only span into whatever backend buffer this has.
Well, but the data is not stored as a span, right? The data, like the binary data, holds onto the data as a read-only memory of byte, right?
Yeah, it's not implicit from read-only memory; it's implicit to read-only memory.
Oh, sorry. Okay, yes.
Yeah. So it seems like if we can go implicitly to read-only memory, we should be able to get implicitly to read-only memory as to read-only span as well. I understand that going from a memory to a span is not super cheap, but it's still an O1 operation, right? It doesn't do any copies.
Correct, it's still O1. I don't think we actually have many types in the framework that are implicitly convertible to read-only memory. I think we say that they're implicitly convertible to span just because it's used in more places, and we have like .as memory methods if you really wanted the memory out of it. I think that's a pattern we've already established, but I mean, someone can correct me.
But I think I agree. If we keep the conversion to read-only memory, probably it makes sense to add one to span as well.
Yeah, I mean, our general stance, I mean, it's a written guideline, is don't have an overload that allows a read-only memory and a read-only span as alternative options. I mean, this violates that. But, because yeah, basically right now, if you said new binary data of binary data, I think it'll actually, yeah, it'll JSON serialize it because object is better than the implicit conversions. And if we got rid of the object constructor, then it would fail to compile. So yeah, really it's a question of how many types are going to be like this and ignore the guideline to not overload across read-only memory and read-only span.
I'm not sure, Jeremy, can you repeat what the guideline exactly says? Because I don't see.
I think it was do not overload across read-only memory and read-only span, but let me look up the exact wording.
But where is it overloaded?
The constructor.
Oh, okay. We are not.
And
sorry,
from bytes.
I thought we are talking about the implicit operator.
Right. So this is if it can implicitly go to both types, then anywhere that does have method overloads that vary on read-only memory versus read-only span, this type is now, it can't be implicitly passed there because it collides with two methods with equal precedent.
Right.
Yeah. By the way, I would. So I see what you're saying. Yes, which is another point. I'm considering maybe we should remove the read-only span constructor. Basically, the main scenarios are I create binary data from object, from string, or from a byte array.
Yeah, if the from bytes and from, I'll say from memory, but it's from bytes. If those are both holding weak references, so they're not making defensive copies, we should get rid of the span so that you are the one who called to array and see when the copy happened.
Yeah, I mean, I think it's fine to have a method from, if we have, do we have a from method from span?
Yeah, from bytes.
We have from.
Which again is overloading across read-only memory and read-only span.
Yeah, so we may debate this one. This one doesn't bother me as much, but I think a constructor, I wonder whether, Josh, Ted, what do you think about removing the constructor that takes a span? I mean, span is such a, low level and still exotic type. And I wonder whether we want it in a type that is optimized for kind of high level usability scenarios.
So one question I have though is if the thing you currently have is a span, then constructing a binary data would now incur two copies, right?
Just
No.
one.
Yeah. Because the constructors that take read-only memory and byte array, they just wrap.
Oh, the byte array also wraps? It doesn't copy?
Yes.
Interesting.
Yeah, and anything that requires translation is necessarily a copy. So that would be span to bytes, string to bytes, object to bytes. Anything where the data is already backed by a byte array or a memory, it sounds like, does not copy. Which means that some constructors copy and some don't.
Yeah, and that's another reason why I think maybe we should remove the one that takes a span, and now the semantics are actually, more uniform for the constructors. And then factory methods are a bit more advanced, and they can have in IntelliSense basically describe what's happening.
I mean, you would still have your string constructor copy. You would still have the stream constructor copy, but
that's
we currently don't have stream as a constructor.
Sorry, I thought I must have been looking at something else. Sorry, it's a factory method.
Yeah. Yeah. So the one that takes object and the one that takes string are both making copies because they have to turn the data into bytes. But so I guess they're actually both making translations. But the and the guideline for not overloading across read-only memory and read-only span is avoid, not do not.
So Pavel has a hand up.
Can we always copy in constructors and just add an unsafe method, unsafe factory method?
So yeah. So what I wrote in chat is that's actually what I did with UTF-8 span as well. Like I say it always copies unless you call the explicit factory that says don't. But I mentioned this earlier, but it got lost. Like if you're really looking for something that's really, really high performance, zero copy, I think the appropriate way to do that, as has already been established by the framework, is in your APIs that communicate directly with Azure, you take a read-only memory of byte or a read-only span of byte, and you don't take binary data.
Yeah, but this one, the problem is suddenly you have so many copies. You basically, to read from a network stream, you have to create a byte array and read from it, and then you pass it to this type. And now it's going to make yet another copy of an...
Why am I passing to this type? Like, if I care about performance above all else, then why would I use this type at all?
It's not about all else. We don't want to be, completely wasteful.
Right, but if you're saying that this is return methods from the Azure SDK, if there's the unsafe from bytes, then you would just call that one instead of the constructor in the SDK. So your return values aren't copying, you're using your pre-sized buffers.
I guess the point is more like if you want idiomatic code to be wasteful or in the ballpark of performant, right? I mean, we're not trying to optimize the metal here, but like if idiomatic code like inflicts 5 copies, that seems pretty bad, right?
Right. Well, so the weirdness here really is if you have an object which is, I don't know, some simple type that has 2 arrays as properties, disregarding the fact that we suggest not having arrays as properties. If you say, obj.array a sub 0 and change the value after calling new binary data of the object, that is not visible in the payload. But if you pass a byte array, now that is visible in the payload. So we have 2 of the constructors. Well, one of them we pretend the data is actually immutable, but one of the constructors is made a copy of the data, or rather made a transformation of the data, and the other ones are mutation visible. And
right.
So that's really the but we still have mixed models here on the constructors.
Well,
does that confuse people?
But I think there's, so of course, the constructor that takes object and a string, the payload is not stored the same, there's a transformation going on. The other ones, well, that's how array behaves. I mean, hopefully we are not saying now that arrays are unsafe in CLR or in C#. Arrays are safe, and yes, you need to be aware that when you pass arrays around, whoever passed the array in can mutate it. I mean, that's C#.
Yeah, I mean, it seems to me like both. I mean, if both the byte array one and the read-only memory just wrap, then in both cases you would observe the modification to the underlying data, right? And then in string and objects case, it's like, well, you have the data in a different shape, so you would be hard pressed to observe any differences there, anyways.
Right, and I'm just like, this is really just them making sure we think through it, because while we all understand that, does somebody in CS1 understand why some modifications don't show up and other modifications do?
So my question is then, like, following that rationale, should we remove the from bytes method as well? Because whatever we say about the constructor would also hold up for the overloads of from bytes, right?
For which point? Getting rid of the one that takes span?
Yeah.
I think so. I think we're getting rid of the one that took span.
I guess I'm.
If you're using span, then you can know to just call .toArray yourself. It doesn't.
Yeah.
I'm
really-
fine with that. Yeah.
If we have one that just wraps, I think it's fine. And I think like if those are wrapping and those are wrapping, then it means in the default case people wouldn't accidentally make copies. Because the object one and the string one, like I think it's fine to say it kind of implies that they are copies, right? Because they have no way of actually wrapping the thing.
So why are we keeping the read-only memory one if we're getting rid of the span one?
Because the read-only memory one doesn't copy, it just wraps.
And it's literally the representation that of the, you know, how the data is inside represented.
What if I have some? What if I am? I guess we're intending more advanced scenarios, like I'm operating on chunks of data to use something like binary reader instead.
You mean like a sequence of buffers?
No, like I have a byte array, and I've got a sequence of objects that I want to pull out using binary data, and then later on in the same array, because it's from a binary file on disk, for example, I want to pull out a separate set of objects instead.
Yeah, I don't think you can do that.
Well, you could if you copy, but you're going to have two copies if you don't have a span overload.
I'm still not understanding what you mean. Are those two different sets of objects that you want to pull in different ranges in the array or in the same overlapping? Well, then you just do read-only memory. Read-only memory you can slice. So you slice two ranges and you create two of these.
Well, the problem will be you don't know where the object ends, right? So you would have to literally deserialize it to know how much to read, right? In which case, I would say you're no longer using this type, because to me, like
right, it was. Now we're back to what's the purpose of the type. If it's something like the Azure SDK is, I'm going to store something for you. It stores it in bytes. Give me a thing, I will shove it in storage. When I give you a thing back, I give you this, and then you do the inverse of whatever operation you did to make one.
Right.
Like you're not using that to read from a file and figure out where the first object ended, and like it's always representing the entirety of one payload.
Don't we have to copy for every single one of these constructors?
No.
Why? You mean just general defensive guidelines or technical reasons?
Technical reasons. A memory is implicitly convertible to read-only memory, so therefore it's mutable. You can't assume that a read-only memory is not mutable.
Well, but that's the same as the byte array, right? I mean, the idea is that this type wraps it. So if you pass in data that you can still hold on to and mutate, yes, you will be able to observe that, but that's on you. I think that's what we are saying.
Yeah, that was the discussion moments ago.
I mean, it's not called immutable binary data, right? It's called binary data.
Yeah. So for every one of these, we will just store the array or read-only memory as given?
Yes.
That's right.
Yes, holding the reference instead of holding the values.
Doesn't that work counterintuitively to how most of our APIs that take arrays work?
Sort of.
I mean, no, I don't think so. Memory stream, when you wrap an array in memory stream, we don't copy the array.
I think memory stream is a very specific scenario that's at the far edge of what most types, like if you use any of the collection types, you give an array, it gets copied.
Well, but I think that
almost every case in the framework, if you give an array, it gets copied, except for several rare esoteric scenarios.
Yeah, but I think the scenario is very similar, right? So memory stream is not a type that lives long, right? It's a type that you have temporarily because you want to, either read data in a stream fashion that you already have, or you want to basically expose, sync something into it, right? And binary data is very similar. It's not a thing that will live long in the app, right? It's basically an interim type that you use to basically transcode data into it in a convenient fashion and then have it stored somewhere. Like collections are different, right? Collections are permanent things that live for a very long time potentially in your process, and they're very often part of an object model where modifications to it need to be observed and stuff like that. So that I think that's why they're very different behaviors. Like things that hang around, you don't want side effects, right?
Yeah, I agree with that one. In addition, I would say the difference between collections and this one is here the array is basically representing a byte buffer. And in the collection examples, array is a collection of items. So yes, for collection of items, we usually we are fine to copy because the bulk of the data is in the items, not in the collection. And here, basically, we would be dealing with potentially large buffers that are just bytes, and we kind of copy the bulk of the data.
Okay, so
yeah, I think when I did the analysis while we were doing the third version of the guidelines, it was basically 50-50 on byte array. Things like array segment are wrapping it as a reference. Things like memory stream wrapped it as a reference. Other things copy it. Yeah, it was a mess.
all right. Should we seal the type?
I'm sorry, there is a conversation in chat, a class versus type, where Levi says most people believe it's a struct, and then Jeremy says, I think we're solidly on a class.
Yes.
So let's figure that one out.
I mean, that's the second bullet on Emo's notes. Like we discussed that about an hour ago.
Yeah.
Yeah.
I guess now it's the fourth because he scrolled.
Yeah.
Sorry.
I thought it was about subclassing, but that conversation just kind of fell by the wayside. Like, do we see scenarios where we'll subclass this?
I see scenarios where you would want to subclass it to change the serialization options. So the users, when they call, from stream, maybe not from stream, from object. Where is it?
Is the idea to have us make something future proof, or because you expect third parties to go and subclass us? Because if you expect third parties to do it, then we can't seal it.
Yeah, that's a good point. Like if we don't need it now, we could temporarily seal it, but I don't know.
Yeah,
are we getting anything from sealing it?
If it's unsealed with no virtuals, the only thing you can do is change what the constructors do on the way in. You can't change what toObject from JSON, or as it's currently called, toObject as JSON, can't. Like you can't change that because there was nothing virtual. But sealed class does mean we have the option of doing unsealed with virtuals later. Unsealed class means that if Azure SDK thinks it's easiest to make a, queue-based data type that extends binary data as the return so that you don't have to always pass the JSON serializer options, that you did it with the type name instead of with the second parameter, then it gives you that ability. But again, you're probably just calling the static, and you would just call a different utility static that passed in the options and called the one that you wanted. So,
I mean, really, sealing buys you that you can unseal and add abstract later, right? You can always add virtuals later, but you cannot add abstracts later if you don't seal it now.
Is it legal to make I forget, is it a breaking change to make a non-virtual method virtual in the future?
It used to not be, but now it is.
What? Why?
Because of question mark dot.
It's sort of
because the compiler passes it with call instead of callvert, if it's question mark dot and it already knows that that it couldn't have already been null for reasons, and therefore if you change it to virtual later, it won't virtual dispatch until the recompile.
So are there any methods here? So if we make this a class and seal it, are there any methods that we need to declare as virtual just to be extra safe for the future then? Is that even legal? I think it's legal to do that.
No, I think we would keep the publics public. We would add new protecteds, and the publics would call the protecteds. Like, we wouldn't add new public virtuals.
Yeah, I think that's generally the way we would do that. I mean, frankly, like, I would not make things virtual just in case. It seems like a weird way of future-proofing. I'd rather do what Jeremy suggested. It's a cleaner thing, and probably...
It's also our recommended pattern, is not having public virtuals.
That's going to make this really hard to like mock, for instance, but whatever.
Yeah, but like, why would you mock this type?
Yeah, you mock it with read-only memory.
Sure.
Yeah, I mean, it's like trying to mock string. It's like...
You build it exactly the way you want it to look.
I'm really just not a fan of like delegating to protected virtuals. It's like indirection is whatever.
Right, but anything that takes like these, the twos are all, well, most of the twos are 0 argument. So the template method pattern doesn't give you standard argument validation, but
yeah.
I know that all the crypto methods that have virtual, you get different argument validation on every subclass, and yeah, as we all know, crypto was done wrong.
I have one last comment about subclassing. It would work terrible with all the factory methods we would have. Like, if we ever add q binary data and somebody would try to type q binary data dot from bytes, what would that do?
Sadly, that works. I wish it didn't. Yes, it'll call binary data from bytes.
But it would give you the wrong type, so you won't be able to call a method that takes q binary data.
Well, you could always method hide. You could method hide if you need to.
Yeah.
Oh, so okay. So with the new, it would work.
Yeah.
Okay.
In fact, this is how part of the crypto stack works too. It uses method hiding for static factories.
Only because the base classes shouldn't have had them in the first place.
Yep. But no, to your question, I think that was Pavel who was talking. To your question, yeah, there are ways around it.
I mean, you can basically make that, like, it's like subclassing is not just, for basically storing that in a union fashion, right? It's really more for shortcutting the constructor, right? So for example, let's say I have protobuf binary data, right? And that my constructor just does protobuf serialization and then calls the base constructor with read-only memory, right? And then instead of going factory-wise, I can just still new things up. I can say new protobuf binary data, foo, and then the right things are happening. And that seems useful, right?
Mm-hmm.
So is this an alternative to more factory methods? Is it like discoverability thing?
Well, it's mostly for the. I think the question is, who is the extender here, right? Because we are the only party that can add new static factories, right? But anybody can derive the type, right? So it's really more for the user to have some syntactic shortcut that is not crazy on their end.
Yeah, and certainly the protobuf data extends binary data can add from object as protobuf as a static method on them, and because all of these things are doing is just do some work and then defer to the constructor that takes read-only memory.
Yeah. And if the language ever does add like extension everything, then you can always define your own static factories too.
Right.
Imo, I noticed you removed the editor browsable attributes.
I did, yeah, but mostly because I don't care for the API review. I mean, like, you can, I mean, in general, I don't care about overrides because they're already there. If you want to hide them, be my guest, but like, I don't care.
Okay, because we don't want to hide them, because we don't want people to be calling equals and get hash code. Also, we don't want this type to be a key in a dictionary. And
right. Well, I mean, like, while you guys have that as a rule in the Azure SDK, we certainly don't have that in the BCL. Like, we don't EB never these overrides.
I mean, my question is, can you explain on like why you care? Like, you're saying, even if you do that, like, what prevents anybody from just throwing this thing into a dictionary?
No, that's fine. They can do it. It's just there are methods that we don't want people to call, yet they clutter IntelliSense. That is basically the reason.
Sure,
We
that
noticed
one seems
that
fine.
if we hide them, IntelliSense is less cluttered. So then people typing dot discover toStream and toString more easily. Like for example, when IntelliSense is cluttered, people don't understand that toString actually does something useful. You know what I mean? They basically just gloss over equals get hashcode toString because they see it everywhere. When we hide these methods, you realize that when you type dot, you will see literally 3 APIs: 2 bytes, toString, and toStream, and toObject. And suddenly, like the options are what people want, so they kind of look through all of them, as opposed to missing the toString because they see it as a package of get hashcode equals and toString. And they assume that the toString method is useless.
Yeah, that's my expectation too every time I see it in IntelliSense.
I mean, again, guidelines say basically you should never have a legitimate call to something.toString in your code. It's just for the debugger. There are types that do that differently, but that is what Christoph wrote in the previous 2 versions of the book.
I think we violated that in so many places in the BCL at this point. Like I don't think we can take that as a hard and fast rule anymore. Like read-only memory of char and read-only span of char. Like we tell people toString is how you string it.
Yes, because that is, sadly, we had toString as a general thing tied into the debugger, but it is also the name that you would take something that takes it and actually does convert it into a system string in a meaningful way. And yes, we don't have a way of indicating that toString is real other than be like, yep, totally, absolutely call it on this type.
Yep, it's fine. I think I think people will just try toString just because they see it, it's there, they call it, see what it does. Oh, it works, sure, whatever. And just keep using it. Like it's not a huge problem.
I guess this toString is actually UTF-8 decode.
Yes, so we do not want to hide this one. We want to hide the other 2, but leave this one. So
because this is undoing the string constructor. So this one's not debugging display. It is rehydrate a string from this binary data.
Yep.
I also think we can't say don't use toString because WPF, when forms in every other binding library in the universe, defaults to using toString for display purposes.
Yep.
I'm just telling you what the guidelines have said since Christoph wrote the first book. It says do not depend on toString when you're calling it.
We should do.
Jeremy, that's not. I think you.
It's a hyperbolic version of what the book says.
Okay.
Yeah. And equals and get hash code, we just say they retain their existing default implementations, object or referential equality.
Yeah.
Okay. Sounds good.
I think they were only being overridden just to put EB-never on them.
Yes, exactly.
So one quick question about the name. What was it? ToObject as JSON?
That as should have been a from.
Okay, yeah. I feel like as is kind of confusing and from might be a little bit safer.
Yeah.
Sorry, which one is that?
Line 36. So ToObject as JSON reads kind of funny.
ToObject from JSON. Yeah, I think that's what I meant anyway.
I just had a question. I guess this is mostly for Ted and Christoph, but so like for the Azure libraries, we still want to support from objects and from object async that work with object serializer. How would we actually implement it with this new model?
We would serialize to byte array and create an instance passing the byte array.
But where would it live is the question. And I think the ideal will be static extension everywhere statics. But for the short term, where do we want to put it?
So let's talk about this separately. I mean, as long as you feel that we can implement it, we can talk how we design it. And unless you think that like it's related to the work in the BCL.
The only thing is basically if we do subclassing, would we want to subclass it ourselves? I personally don't think so, and I don't think we have a scenario for subclassing this on the Azure side. So I would actually push back against leaving it open to subclass from our perspective. But we can solve our specific stuff off of it.
Yeah.
What about Hall's earlier suggestion of having a specific constructor that is a zero copy constructor for the incoming payload.
I thought that what we landed on was that the ones that take bytes already are zero copy.
Yes.
I thought this was being viewed as array segment.
Oh, okay. So we're okay with being in a world where some of the constructors copy and some don't.
No, all of them don't copy.
The
No,
object and string would obviously copy.
Yeah,
Well-
when it translates into bytes, it copies, but
Yeah.
when you're just working with bytes, it wraps it.
They encode, which creates memory, but doesn't necessarily copy the way that we're talking about.
Right, but if you say new binary data of a byte array, that is mutation visible. If you say new binary data of an object that contains a byte array, that is not mutation visible. And that's the two constructors behave differently to mutation on the next line.
Because they do different things. I mean, there's two of these constructors that do transformations.
Right. I'm like, we all understand.
This is not copy, but this is not copy, correct? Like as Josh was kind of saying, clearly, none of them do really a copy, because copy implies that the data doesn't change;
Right.
It's just getting copied from one place to another.
Well, but this is actually an implementation detail that leaks into the surface of if the object constructor held the object until you called one of the two methods, then it would be, if it was holding the reference, then mutations would be visible right up until you actually executed the transformation. But the transformation happens in the constructor. So now two of the constructors are immune to mutations on the next line of code, and two of the
Sure.
constructors are not.
Okay.
I mean, just like that's the level of, you flip these two lines of code, does something change? It depends on what the type was that you passed into the constructor. And I can understand this model. I can wrap my head around it. Probably most people can. Very few people actually attempt to mutate things after they pass it to something like this, but it's like if you do new binary data of something in the array pool, and as long as this object's alive, you still have a reference to the array pool, or the array that's in the array pool.
To me, it really boils down to like how long do people normally hold on to these, right? If we assume most of the time people knew it up at the point where they call the API to process the data, it probably in practice it's fine. It really comes to a problem when people hold on to these guys for long, and then because people don't really intentionally mutate after the fact, right? It's usually an accident by some other means, and then they realize that their data becomes inconsistent in various ways. But like, I don't think people hold on to this type for long. Like, it's not
Right,
a type
like
that you would do that with.
The thing that would be the most likely to be bugs with this model, and so we can see if that sounds too scary, and then we can add the unsafe from bytes that doesn't copy as the workaround, is you rent something from the array pool, you do some work into that buffer, you call new binary data of the read-only memory of the slice of your stuff in the array pool.
Right.
You've returned, your finally returns the thing to the array pool, but the thing that you returned this to, put it into a queue to get around to uploading it later. Now something else takes that array out of the array pool, starts mutating it.
Right.
All of your code looks good, all of their code looks good, but you now have data corruption because you used the array pool and something else grabbed that same reference. And so the answer for that would be, if you use the array pool, you have to call as span to array, or array.copy. I guess array.clone and then cast it. And
At
it's
which point you
like
may as well not even use a pool.
I was about to say,
I
like,
would say that's a general thing with array pool. When you're using array pool, you just cannot pass these things around, and like array pool is mainly for your code.
yeah, I
right,
was-
but it's if you thought it did a copy, or every time you tested it, it always got synchronous completion, so the data was immediately uploaded, and you never saw that it went into a queue and had a delay. You never see the corruption, and then you hit production, and now there's actually load in the queue. You get enqueued instead of immediately sending, and now you get data corruption.
Yeah, to me, it depends on what your expectations are. I think fundamentally, you said your code looks fine. If I rent an array from an array pool and I pass the array to somebody else that I then just, return or whatever, like that to me seems fishy. Like, unless you really
fair.
know what's going on there, that seems like a bad idea.
That's the
What if you
biggest weakness that I see of the current model. The biggest room for bugs that I see is using array pool or any other.
Ignore the array pool. What if you access the ASP.NET request?
What if you is the request exposed as an array?
I believe the request. I believe there are APIs that give you the request as a read-only memory of byte, but that read-only memory of byte is valid only for the lifetime of the current request, at which point it's returned back to a global pool.
You're talking about the new pipeline APIs.
Yeah.
Yeah, well, the pipeline APIs are fundamentally kind of, tricky to use.
Sure.
And they are basically like the pool.
But
So
I would say
beware. Okay.
But even in that case, right, most customer code is probably safe too, because as I said, like the most likely thing you're going to do is you call an Azure API or something like that, right? And then pass the data into that, and they basically send it over the wire. So when they return to you, well, then you are done, and then that's the end of it, right? You not need, like, as long as there's a party or there's no party that holds onto these things for a long time, it's fine. And these things that transport, like, they're not meant to stick around, right?
Yeah, in that case, it would be that you call threadpool.queue work item to send it to the uploader, and you passed, request body.slice A to B, right? Like,
right.
Again, the code looks sane until you're debugging. Why did we upload something other than what the request body said to do?
Yeah,
fair enough.
I would say this type is fundamentally not really for usage with pooled memory, and it's not. And adding a copy to the constructor wouldn't fix the problem, because then why are you using pool in the first place if you then making a copy every time you have to pass the data around?
Yeah,
that seems okay. All right.
Yeah,
Again, if you were just calling the Azure SDK APIs directly and they took a byte array, you would have to keep the byte array immutable during the lifetime of the operation anyway. This is really, like you said, that's really no different.
Yeah.
Yeah, no matter what we decide here, like in 2 years from now, somebody will point me to this YouTube video and said, "Ha, you said this thing," and turns out you were wrong, right? So
yeah,
it's fine.
The fact that this keeps coming up over and over and over and over again, like, we really need to just sit down and figure out, like, lifetime management issues with the runtime and data. Like, seriously, this keeps coming up all the time.
It sounds like you're saying we should just figure out world peace. I mean, that's
we don't even have to figure out world peace, right? We just need to figure out memory ownership piece.
Yeah, but I think that is the
I think world peace is slightly easier.
Yeah, I was about to say, isn't that like the goal of every modern language invented after C++, to just make lifetime more bearable?
There are ways to do this that we can discuss offline.
All right, so make sure you file a patent for this, because it seems like a patent-worthy idea. All right, so let me just... Oopsie, now let me find my thingy here again. So, in terms of next step then, so given that we kind of run out of time for this type, so we will assign a dev, we will basically implement this as fast as we can. I didn't hear any pushback on the assembly name or the package name, so that's what's going to happen. The thing will obviously target net standard. I didn't say that, but like that's kind of implied. So, or net standard 2.0, I should say. Anything else, or does that remove all uncertainty and doubt? Okay, I didn't hear anything else. Then I think we can.
Sorry, is somebody on your team going to own implementation of this? Or are you going to take the one that we already have and just ship it as fast as possible?
So yes, if you already, so I wasn't sure whether you have an implementation. If you have one, by all means, share it with us. That makes it faster for us to implement. But yeah, I mean, the idea is that we own the package moving forward, right? So we would own the bug fixes and whatever comes with that.
Thank you.
We have an implementation because we already shipped several previews. This type has existed for, half a year or more.
There were, of course, changes during the review here, so changes will be necessary, but definitely a starting point is useful.
Yeah, if you write the whole thing in F# again, to make it bug free, right? Anyway, all right.
I heard it will be in Common Lisp.
COBOL.NET.
No, in Lisp.
But I don't know what the Lisp bridge to .NET is, but I know that COBOL.NET recently updated to support .NET Core. So
you write code in Lisp and then translate to C++. I heard the story.
Isn't that how the GC was written?
Exactly.
God, my computer is so slow. I just clicked on the meeting. I just want to see what's next on the item. Like, how hard can that possibly be? All right, so we said the next thing is multiply high. Is Igor still on the call, or did we lose him in the process?
It looks like he's on the call.
Can you hear me?
Yep, now we can. Let me just open this guy. All right, so can you see the screen?
Yeah, this is gonna be easy. It's basically just exporting two instructions in ARM64 base ISA that allows to get upper 64-bit of 264-bit numbers multiplied. It's similar to what BMI2 does on Intel, but it only produces upper 64-bit, not upper and lower 64-bit parts of the multiplication results. And it also supports a signed version, which I believe is not supported by Intel. And why it's needed is basically like allows to implement big mal methods using the snippet I also quoted.
I mean, as long as it's in the right place in the hierarchy for where those instructions live, seems good to me.
Yeah, I was about to say that seems.
It matches the left and right, or what we called the vector multiply highs for x86 AVX. So seems good to me. And I trust Igor and Tanner to pay attention to which ISA it goes into, or which class we have that maps where it is in the ISA.
So I was in a nested type, right? So it would be. It would be more like this. Was it ARM64, I think? Yeah. All right, so then given that nobody else said otherwise.
All right, now we're down to a 45-minute average per issue.
Well, I mean, one of them was harder than the other, so there's that. Environment process path. Is Jan still on the call?
Yes. You have camera with no audio, Jan.
So he's trying to talk to us, but we can't hear him.
Yep. I don't see the mute marker, but I see lips with no sound.
That seems like Teams is using the wrong mic.
Hey, can you hear me now?
Yes, we can.
Yeah, so this is there is a common pattern for with the heavyweight system diagnostic process that this API can be used to replace. So it's just a simple pattern match analyzer. You know, look for the one sequence that's way more expensive and suggest replacing it with a different with this API.
Oh, I see. So this is just asking for the fixer for that, or the analyzer plus fixer, yeah.
And this is specifically just finding where you've called it on get current process main module file name, not all accesses of main module or all accesses of file name.
Yeah, exactly. It's basically pattern match for that whole thing.
Seems good to me.
Yeah. That one seems pretty easy. All right, so then what was the next one? I think similar one, right? The managed thread ID. Same idea, I suppose, right?
Yeah, same idea. And, pattern match.
Yep. Anybody any concerns with that? Because that seems totally reasonable.
No, it seems terrible. No, we should do it.
The only thing, I don't know how common these patterns are, but if we have more of them, we should consider whether we can generalize this somewhere so it's not terrible to implement.
Maybe. I mean, I guess one thing, I don't know that it was in the issue. Do we know, are those, two separate diagnostic codes, or do we want to put them together into one diagnostic that you either want on or off with performance rules, or?
That's an interesting question, what we do with that.
Like, would you want one of these rules turned on and not the other, Jan?
I think we had some discussion about it. I think whether have like one ID for all of them. I think the discussion was leaning towards kind of grouping them. Let's say have all the ones, maybe all these three together make sense. But if there is another pattern, say for, I don't know, file stream, then maybe it should be a different analyzer because of it's a different kind of class of APIs.
Yeah, my recommendation for the ones that we just introduced the new environment accessors for, at least the two that we just saw, is if you would want them to be turned on or off at the same time, like that you say, show me all my performance improvements I could make, that we should just bury them in the same diagnostic ID. So probably means the same analyzer and the same fixer, but at least the same diagnostic ID.
Yeah, that makes sense.
But by the way, we have just introduced a similar analyzer a while ago for environment process ID. So I would assume that it should just reuse the ID for that one. Is that what you are saying? Or?
Yeah.
Yeah. Unless adding unless that package is shipped and we think adding new things to the same diagnostic ID is a breaking change that you don't want to take chemo.
No, God, no.
So if the analyzer version hasn't gone stable yet, then add it to the same one, and if not, then a new diagnostic ID, I think.
Mm-hmm.
I think in general, I think we should be able to add to a diagnostic ID. It's just that it needs to be the similar case, right? So for example, for obsolete, we said if the API is part of the same obsolescence logically, then we just reuse the existing obsolescence ID, right? It's like, it's not a runtime breaking change. It's more like, what do you expect the developer to want when they already suppressed one of them, right? Would they expect the new one to also be suppressed? If so, reuse the existing one. Like if you don't want the existing one to suppress this one, then make a new one. But I guess for all these shortcut helpers, if you don't care about one of them, it's probably fair to say you don't care about any of them, right? Like it's really about what expectations do you have when somebody suppressed that. But it's not a breaking change.
Okay, so you would just shove them all in the same diagnostic, even if it did ship?
Yeah.
Okay. You're the UX guy. I just ask questions.
All right, so I think is Carol on the call? Jeff is out, I think.
I'm here, Emo.
Oh, you're there. Okay, cool. Then should we look at the one from Jeff?
Yeah, sure.
Okay, that's the. Which one is that? That's the validate.
Third one.
This one here, and then this one, right? You want to talk about it, Corey, or?
I'm actually not familiar with this one, so I'm just trying to understand. It looks like this is not networking specific, but more just streams.
Yeah, we can skip this one. I mean, like, it's fine. Like, if we go through as many as we can.
Yeah,
Yeah.
I mean, it's a great scenario, but you can do it by instantiating an array segment and just letting its constructor handle everything for you.
It would probably get the parameter name wrong for buffer being null, but
yeah.
Otherwise, yes. So you'd still have to do a argument null check on buffer, but then you could just use the span memory or array segment constructors, and they'll validate offset. And I think they may call it offset and length though. So again, the name may be a problem.
Sure, it's a good scenario though. I would use it.
Yep. Okay, then let's do it separately maybe, and then this one here. Does anybody have opinions on this? Is that the one that you can represent, Corey?
Yeah, we're just adding an API that kind of went missing. Just adding an IP endpoint overload so people don't have to pull out the address and port manually.
Right.
So the synchronous connect already exists?
Yes, although I don't know why it's returning a task in the proposal here.
Yep, capital E, capital P is how we spell it there. So that double capital looked weird to me, so I just wanted to make sure we were being consistent within the same type at least.
Yep.
Yeah. So
seems
it's fairly straightforward, just a convenience method.
Yeah.
Is there a reason that you need the connect async that doesn't take a cancellation token? Is it semantically different than passing cancellation token .none, aside from the fact it returns a task instead of a value task?
I think it's not different. I think it's just for consistency here.
Okay.
The usage we see, typically people will not need a task. Like a value task performance is worth it.
Yeah, I mean, like, so if this was a completely greenfield API, we'd say don't have an overload, just have a defaulted cancellation token.
Yeah, I agree.
And I don't know, given that they already exist, overloading like this may make more sense if people are looking in like at method group documentation.
So we had a similar question when adding some socket APIs and came to the conclusion of having two separate overloads. So I think it's consistent to do that here.
Yeah, okay. Consistency within the member family is good, I think.
Yeah, I agree. Because every time you try to be clever, it usually backfires. So to say, I'm slightly concerned that my comment disappeared, but all right, then okay, we skipped the one from Jeff. So then, Levi, I think you're on disable private reflection.
Yeah, so there's an attribute, the disable private reflection attribute. It doesn't do anything in core. We should obsolete it. You apply the attribute when you want it when you want the runtime to have a side effect of preventing things like activator.create instance calls to a particular type inside of an assembly. But in .NET Core, we don't consistently respect it. So if the only reason to apply the attribute is for the side effect and we don't do the side effect, nuke it.
I didn't know we had that API.
Yeah.
Me either. Is it we don't respect it, or we don't consistently respect it? And if we don't consistently respect it, what does it do?
So it's, I believe it's tied to the code access security infrastructure as an implementation. And because we don't really call the CAS infrastructure anywhere anymore. Yeah. So like I said, the original goal of it was to prevent things like activator.create instance of a particular type that was listed as non-public. But again, like in core, those code paths aren't activated. So yeah.
Okay. Yeah, like if it does nothing aside from anything where anybody themselves is inspecting it, then I would say it does nothing. And then
in core and 5.0 it does nothing. In full framework, it does confusing things that no one expects.
Okay, and I assume we already know what prefix it would use, and it just gets the next number for diagnostic code.
Yeah, so I had listed here that we could just straight up obsolete it without a diagnostic ID if we wanted to, but I don't feel that strongly about it.
I mean, if somebody's cross-compiling, I guess they could pound if their call away, but like, while the obsolete will only show up if they target net6 specifically, like if they are cross-compiling for net6 and netfx, it's just more annoyance. If
the recommendation here, by the way, is going to be deleted in all cases, even if you're targeting net framework. It's so inconsistently honored in net framework that there's really no point to use it. Also, like if someone's hell-bent on using private reflection, they're going to do it even without this attribute being present, or even if the attribute's present. There are ways around it.
Is this possibly a scenario where we want to say this obsolescence is only valid if you're targeting net core only? Because I imagine there's a few places where if you're multi-targeting, we don't necessarily want the obsolescence.
Well, the obsolete attribute's only going to be on the newer reference assemblies. We're not going to obsolete the APIs in already shipped reference assemblies. But when we write up the documentation for this, the recommendation will be don't if-def it, literally just delete it everywhere you see it in your code.
Yeah, I mean, like, I don't quite understand the concern with multi-targeting. I mean, this is true for any discrepancy in API surface, right? Which is the reason why you do multi-target in the first place. So I think, like, it's fine to say you multi-target between 3 platforms and only on one of them something is obsolete, and then you have to make a decision what you want to do, right?
Yeah.
I feel like that's a case-by-case decision that the person has to make.
Yeah, for those, what we say is you can... Because the API that you're calling, which is now obsolete, might have had a side effect or might have had an implementation on an earlier framework, then in this case, either if-def it or just suppress the obsolescence. But in this case, like, our recommendation would literally be, like, if you're using this on full framework, stop, delete it. If you're using this on net core, stop, delete it. If you're using it on mono, stop, delete it, and so on.
I mean, for something that works on .NET framework, but in core we're saying we don't respect this anymore.
What works has a gigantic asterisk next to it, by the way.
So yeah, but just the in general, if it has a diagnostic ID, then you can just add the no warn in your project when you're multi-targeting, and then it goes away. And that's my question here: of does this get a diagnostic ID? And
if we want to, sure. I don't really care that strongly, but if we want to, then we can.
I would generally say yes, we should. I mean, like, I'm kind of hesitant to say we should do it for all obsolescence, but I think, when in doubt, we probably should. In this case, I would just purely do it because I think disabling private reflection will probably come up, and people will say, look, there's an attribute, and so it would be nice if you could describe in a bit more detail on what this attribute is and what it isn't, which you can't quite put in this one-line sentence. Because it sounds like kind of we ripped out like a large part of the functionality of the CLR, which we clearly did not, right? So.
I mean, plus having the diagnostic ID means there's the docs page for it.
Yeah.
But just to clarify, the recommendation that we write on the docs page is going to say, regardless of which framework you're targeting, even if it's full framework, we recommend you delete the attribute where it exists.
Yeah.
Okay. Most of our other obsolescence do not have such a message.
Yeah, I mean, I don't know, like, whatever we write for binary formatter would probably be in a similar bucket, right? Like, you should not use it no matter where you are.
Well, but there's, in that case, we want to recommend replacements In this case, like we're recommending literally delete code. Don't add code. Just highlight the line, hit delete, and then go about your day.
Right. I mean, I guess maybe that's a bad example, but I guess CAS would be similar, right? Don't do partial trust, even if you're targeting on full framework, right?
Yeah.
All right. I think the next one from Levi is just another quick analyzer, so we can knock it out, and then we're probably done for the day.
Yeah. There are cases where people do a somewhat expensive operation of like newing up a cryptographic hash routine, hashing data, and then just disposing of the thing. We have static one-shots that were introduced in the previous framework, or I'm sorry, that were introduced in 5.0. This just rewrites it to be more efficient.
I love it. I've written code like this 100 times, I think.
Yeah, I mean, it can't do it if they've actually used polymorphism, but yeah, I think finding the cases where it's provable like this and doing it seems good.
It turns out this pattern occurs frequently enough where the fixer, I think, has value.
Yeah, I think it frequently occurs inside static utility methods that someone has written for. Why isn't this a one-shot?
Yeah, I mean, this makes sense to me. I think the general question here is like, I feel like we will have a lot of those over time, so.
Yeah, did we also do one, to your recollection, Levi, for RNG fill versus RNG get bytes?
I don't recall.
Because we might just want to do both of them at the same time. I mean, not that they're necessarily the same analyzer, but it's still we added a static one-shot method to avoid some object creation confusion that people have had, and a place where things were polymorphic when they didn't need to be. And it's crypto.
So
I was just like, it's why I'm thinking of it in the same space. We added the utility methods to make life easier, and
when you say like polymorphism, what part do you mean? Like when you go through the factories?
So the other one that I'm talking about is on random number generator. It's the crypto one, not system number. It has a virtual method called getBytes so that your RNG can fill the array. But we said that no one should really subclass the type. You should just use the system RNG, and then we added the static RNG.fill. And so if you're so the get bytes is polymorphic, but we tell people don't use any classes other than the one we give you. So why was it virtual? So why are you creating an object? Right. And therefore it's the same analyzer as this, as you don't want a virtual behavior of hash data on SHA-256. You just want the right answer to come back.
Yeah.
In the case of SHA-256, there is the parent, which is hash algorithm, which is you can accept any hash algorithm and produce some bytes. So there is a polymorphic semantic behavior there, but for the RNG, there really wasn't. But
what we might want to do then is just so as a separate analyzer, just tag any instances where an RNG is instantiated for any reason whatsoever, and say you really should just be using a static API. But we can do that separately.
Yeah, it does seem like a separate issue, I guess. I was just thinking of a similar pattern of we added a static method that we think you want to call instead of the instance method. So
yeah.
Alrighty, so then I guess we are now at time. Sorry, Tanner. Next week we can review more of the backlog. I mean, we're doing pretty well. I mean, like we keep it at low numbers and we mostly review everything. So I'm quite happy with where we are right now. Alrighty, then I see some of you guys this week, some of you guys next week.